That's what I'm wondering. I think it's pretty close to going on
Okay, guys, let me talk about the plan for leading up to next Monday. There's quite a few problems that I want us to be able to work through for you to show me. So today we're going to work from some from packet 2, but packet 1, we skipped some of the rate in, rate out problems. I'm not going to check it for homework. It's just going to be for class. But there's one more problem that I want us to do. So we're not quite done with packet 1 yet. So we'll do one of those. So tonight, your homework is pages 1 through 6. We may do some of it from packet 2. And whatever we don't finish, you guys will show me. So that will be homework due tomorrow. And then packet 2, pages 7 through 12B, that will be due on Friday. And the remaining ones, you can show me earlier than the 15th, but I need to see it by the 15th to earn full credit. And if you're not here on these days, you can just take a picture of them and just show me that you completed it. Okay. There's also a morning review that I want to give you on Friday, and you can show that. You can show all that to me early if you want. You can also send me email. You can send me, so you don't have to be in person to get full credit. Now, I have quite a few homework here for us to do. I am going to adjust the percentage between homework and the next quiz. So we'll make this 50% of your quiz grade, and this is 50%. So if we do all this, then I'm making you guys do a lot of work, so I'm going to make sure that I can give you more credit for it. All right, questions? You'll get to use your calculator on Monday, but you have to show all your work, and you'll have one rate in, rate out problem, one Riemann sums, and one differential equation. The Riemann sum sometimes can include particle motion in this, so we'll go through some of that. Okay. Okay, so the only ones that have a hard due date are these two. Okay, so tomorrow I'm going to check pages 1 through 6, and then Friday I'm going to check pages 7 through 12B. And if you're late on these, you can still earn 90% of the points for those. All right, so let's do one problem from packet 1. And then we'll go to packet 2. Okay, so if you guys can turn back to packet 1. So packet 1, let's see, page 5. I want to make sure I go through this problem with you, just because it's just a little different, but it's still rate in, rate out. But okay, page 5, number 5. Okay, and I will send out a daily reminder about the homework so that you know exactly what I'm expecting to check. Okay. Okay, give me 1 second here. Okay, so this is from packet 1, number 5. All right, so the amount of water in a storage tank in gallons is modeled by a continuous function on the time interval from 0 to 7 hours, where T is measured in hours. In this model, rates are given as follows. The rate at which water enters the tank is given by this 100 T squared sine root T. That's this curve right here. So you can kind of tell that the rate at which water enters the tank is going to keep increasing, right? So we see that, again, this doesn't tell us how much water is in the tank, just tells us gallons per hour. So if there's so that rate is going to keep rising over the course of the entire 7-hour period. Now, as water is coming into the tank, there's also different rates at which water is leaving the tank from the bottom of the tank. So between 0 and 3 hours, there's 250 gallons per hour that is being let out of the tank. But then all of a sudden, it's going to switch and ramp up all the way to 2,000 gallons per hour. Okay. All right, so the graphs of F and G intersect at 1.617. And then also T is equal to 5.076. Okay, and the amount of water in the tank is 5,000 gallons. I just want us to kind of visualize a few things here. So there are two things going on, right? You have water coming into the tank, you have water leaving the tank. But what I want us to kind of observe is what is happening to the level inside the tank. And can we make some general observations about when the water in the tank is rising and when the water in the tank is falling? So I want us to think about what's happening between 0 and 1.617. Is the water level rising or falling in this first interval? From 0 to 1.617. What do you guys think? Let me ask you this. Is there more water coming in or more water leaving the tank? Leaving. Because this is higher than the curve. So what does that mean? Water level is going to be what? It's going to be dropping, right? Water level is going to be dropping, right? More water is going to be leaving than what's coming in, so that 5,000 gallons initially is going to start dropping, right? So I'm going to put a red here to indicate what's happening here. This is going to overtake initially the water level. Okay. Then what's going to happen between 2 and 3 hours? Start increasing again, right? Because this curve, the rate at which water is entering the tank is going to keep growing. Eventually, it's going to overtake this 2,000 gallons per hour. That's 2,250 gallons per hour that's leaving the tank, and the water level is going to be rising, right? It's going to be rising in this time interval. I'm going to highlight that. But then at 3 hours, what's going to happen there? It's going to start decreasing again because all of a sudden there's a lot more water that's being let out per hour. Then, even though this is rising, it's still not going to impact enough where that water level is going to still rise. It's going to all of a sudden start dropping. So the water level is going to start dropping here. And then what's going to happen after 5.076 hours? Yeah, that water level is going to be rising again. Okay, so I just want to kind of make those observations with us that the water level is going to be dropping, then rising, then dropping, then rising. Even though at all these time periods, water is coming in and water is leaving the tank. All right, so let's look at part A here. How much water entered the tank during the time interval from 0 to 7? Right, so usually part A is straightforward and easier of the remaining ones. So really the only function we have to involve for part A is what? F of t, right? So we just do what? Yeah, do the integral from 0 to 7 of f of t dt. We make our calculator do the work here. Make sure that you're in radian mode. Make sure you're always using which variable in your calculator? X. Yeah, don't use any other variable, even though you see t on paper. Okay, I got 8,264 gallons. Okay, part B is kind of what we're talking about. Between 0 and 7 hours, find the time intervals during which the amount of water in the tank is decreasing. Give a reason for each answer. So, which intervals will the water in the tank be decreasing?
0 to 1.6.
And then,
3 to 5.076.
and the reason we can just give is because G of T is greater than F of T, right? The amount of the rate at which water leaving is greater than the rate at which water is entering. Yeah. Part C, at what time is the amount of water in the tank the greatest? Right, to the nearest gallon, compute the amount of water at this time. So a little bit of EVT here. We know we want to test endpoints. And we want to test a relative max, right? Because we don't have to worry about relative min here. So where could a relative maximum be? 3, right? So we know that this is when the water level is rising right before it starts falling again. So if it rises and then falls, we know that's going to be a potential, we know it's a relative maximum, but it's also a potential absolute maximum. So, I mean, you can test 1.617 and 5.076 as well, but we know those are relative mins. Those will not have a chance of being the maximum amount of water in the tank. So we can ignore those. But it's not wrong if you want to test additional points. We just don't have to. Okay, so we'll test T equals 3 as well. So we have a certain formula that can, for these rate in, rate out problems. There's 3 components we got to worry about. How much water is in the tank to begin with, how much water enters the tank, and how much water leaves the tank, right? And then if we involve all 3 components, we can figure out how much water is in the tank at any moment in time. Okay, so let's just go down our list of time values. A of 0, what's A of 0 going to be? How much water is in the tank initially?
0.
Let's read the problem again. How much water is in the tank at time t equals 0? Yeah, so over here, right? Sometimes it could be 0, but we just have to read the problem and make sure that we can confirm what's happening in the tank before all this starts, right? Sometimes it's an empty tank. Sometimes there's water in the tank. So in this case, we do have 5,000 gallons to begin with. Right? We also want to test A of 3. So A of 3 is the initial amount, which is 5,000, plus the amount added, which is the integral from 0 to 3 of f of t, minus the amount removed, the integral from 0 to 3. And what is the rate 250, right? Okay, we can do this by hand, but we can also make the calculator do it. This eventually becomes 250t, and then you can plug in 3 and 0 here, but we can make the calculator do all this for us. Now, for A of 7, if we want to figure out how much water is in the tank at 7 hours, we can start from 0, but maybe it'd be easier if we can just pick off from where we left off. We already know how much water there is in the tank at 3 hours, so why don't we just, from 3 hours, we'll figure out how much has been added minus amount removed. I think the issue is if we start at 0, then you have to involve these different rates all over again, and I find it's be easier to just kind of pick up where we left off. So I'm going to say A of 7 is same thing as initially is what I know to be true. Right? I know that A of 3 is, I'm going to start at whatever amount at 3 hours, and then I'm going to continue to accumulate and total up the amount of water added in that time period. But we also want to make sure we subtract out the amount of water that's been removed, which has a different rate, right? 2,000 gallons. Okay, does that make sense? We can start at 0, but maybe it's easier to just kind of start at A of 3 and then fill out the rest. So we know A of 3 is 5,126 gallons. No, this is calculator. Yeah. Yeah, typically the rate in, rate out problems will be calculator. But regardless, you can use your calculator, even if it's non-calculator section. Yeah. But this one particularly, yeah, this one is a calculator problem. Oh, sorry. We want to find the absolute maximum, right? So between these three, which one is the highest? Yeah, 5,126, right? So this one's going to win out.
Say it's continuous and differentiable.
We don't have to, no, not for EVT. You're right. It is one of the conditions, but on the AP exam, I mean, you can write it if you want, but we don't have to. You won't lose points if you don't say continuity. Yeah. But for Rolle's theorem and mean value theorem, those we do need to make sure we include our conditions.
Do we mention EVT in the justify?
You don't have to. You can, but you wouldn't lose points if you didn't have to, because this is really, you're really applying all the steps for extreme value theorem You won't lose points if you don't say EBT. Same with AP exam. You don't have to say EBT.
So how do we justify?
This testing your endpoints.
Oh, the work.
Yeah, your work,
Okay.
right? If you test your endpoints and a valid critical point, that's justification right there. Yeah, we call that the candidates test, but EBT application there. Okay, let's work through packet 2. Go ahead and start with number 1, read the problem. I will walk through the steps, but you guys also have the key. So see how much you can do, see how much you can remember. We'll walk through it together. Yeah, 7. And then you can show me the 22 to 24 later or later today. Tomorrow.
Should I come with you some page?
Yeah. I got a lot of helpful notes at the top of page 1 to help remind you of remind you a couple of formulas and notes. I like part C and D. I think it's good to be able to look at a problem and recognize, wait, is this IVT or is this mean value theorem? Sometimes, obviously, I think IVT is going to be the one that feels easier because if something lands between 2 values that we see and is continuous, we know that point is going to be guaranteed to hit. But if we can't guarantee that based off of our table, then we may have to look at the derivative, right? If the slope between 2 endpoints is the same, then we can guarantee that slope somewhere along that curve. So, yeah. Say it again. Yeah, if we didn't have A of T for D, then we wouldn't be able to, right, then we wouldn't be able to apply it, yeah. Yeah, so that very kind of specific way of working I mean, there's more than one way to do it, but IVT, this is the most efficient way of writing the least amount of information. Yeah, so yeah, practice those things there. Okay, so part A, if you look at the formula here, the definite integral from A to B of absolute value v of t, that's the definition for total distance. Without the absolute value, it would be displacement. So that's part A. Part B, trapezoid approximation. Your formula for trapezoid is width over 2 times height 1 plus height 2. So hopefully that's pretty straightforward for part A. Part B, what does that mean? I can work that out in notation to make it a little bit easier to think about. We know the integral of acceleration is going to bring us up to the velocity level. Plug in the upper and lower bound, I get v of 30 minus v of 0. If we think about what that means, that's just the velocity at 30 minus the velocity at 0, right? So that just tells us how much velocity has changed in that 30-second interval. Right. So if we subtract v of 30 minus v of 0, we can figure out how much has changed in that time interval. So negative 14 minus negative 20. So between 0 and 30, our velocity has increased 6 feet per second in that time interval, in that 30-second interval.
Is it possible to use MVT for C?
We would not be able to do MVT for C. Why is that? Why is that? Why does, and what information would we need if we wanted to do MVT for part C?
Differentiability.
Sorry?
Differentiability.
Something in the table is missing. What layer are we missing here? Position, right? If I'm given a table of values for position, I can do change in position over change in time to get the average velocity, see if the average velocity meshes with what we're targeting, right? So MVT would not work for part C because
For D it would.
well, for D it would, because I can find the slope of the velocity and see if the slope of the velocity is 0. If the slope of velocity is 0, then I know acceleration must be 0 in that time interval.
But then IVT is also possible. D. So like, how do I know which one to use?
Good question, right? So for D, it's possible, but do we have enough information to guarantee and determine acceleration is 0? If you look at your acceleration values, you can look at this and say, well, acceleration is never equal to 0, so therefore IVT doesn't apply. Right, but it's possible that somewhere between the time intervals, the acceleration does hit 0, we just don't see it. So in this case, IVT is not going to quite work for part D because we don't have enough information. But for part D, we can use mean value theorem because we can find a slope between 0 and 60, and the slope between 0 and 60 gives us average acceleration of 0. Then we know there must be an acceleration of 0 somewhere on that time interval. Yes, question.
If it's continuous, does that mean it's differentiable over the interval? Like they just give you continuity, can you assume it's differential?
Let me see. So to answer your question, they tell us that both velocity and acceleration are continuous. Now, if acceleration is continuous, that means velocity is differentiable as well. Because, right, so if acceleration is continuous, then velocity is differentiable. Now, it doesn't say that acceleration is differentiable, but it's okay. We don't need acceleration to be differentiable. We should need velocity to be differentiable if we want to do mean value theorem. So for part D, by Rolle's theorem, since my velocity at 0 is -20 and my velocity at 25 is -20, I know that the slope between the endpoints, there must be a slope of 0 somewhere between. Right, this is my velocity graph here. And V of 0 is -20. And then V of 25 is also -20. Then there's no choice but for this graph to somehow experience a slope 0 in between these 2 points. And we know that there must be an acceleration equal to 0 somewhere on that time interval because my velocity hit the same value at these time periods. Okay, any questions with number 1? Okay, move on to number 2. Okay, let's keep working for 5 more minutes. I did, yeah. So all this just goes in the calculator. I want to see the setup. After that, you can just plug in the calculator. Yeah. Okay, so tomorrow I'm going to check pages 1 through 6 for homework. I will send out a reminder this afternoon. And yeah, and then we can begin class tomorrow. We can I can answer any questions that you guys have on pages 1 through 6, and then we'll start working on pages 7 through 12 tomorrow in class. All right, come get your phones. As a reminder, I got an email advisements. There will be a fire drill, so just give a heads up. No, that's one. I just get it. No, but I like reassign this. I finished the rest of the class. Yeah. I finished all of it.
What happened? No, but like, you know, I don't know, probably like a 75, you know, they used to make it. I was gonna say something, but. You can't drop that back in the semester, you feel like switch schools. You're missing like contact, that's when you just switch. Maybe you could switch like.
Just be front and back, like 7 parts of like 3 and 3.
This ink copy? Or does it use this for
One
videos?
One question. It's in front and back. Something less than like.
Hell yeah, too. Is that a PR? No, that was a missing one.
Yeah, but I just thought I think there's only one.
Oh, yeah.
That probably really outcome.
Oh, yeah.
Is you get it.
Oh, thank you.
What if you
You see the movie.
actually why? That's my
You can't scratch where. You do.
That's funny. I'm supposed to go get it though, for real.
Why not law?
Yeah, but that's the area, and then you have to integrate your area. To find people.
Have a great day, guys. See you tomorrow. Thank you.
It's like, you want to tell me like,
I'm just saying, I'm good.
I don't know, you slide like a $5.
Sure, you're right. I just like.
Kelly, you're going to send out the one.
Yeah. So like, trying to tell me if you
Yeah,
can.
just the basic.
Yeah, the area of the cross sections.
Yeah.
The area.
So it says you have to take the integral. There.
Yeah.
Good day. Thanks, guys.